All right, so at this point in the lesson, the students will have already done 2 introductory Punnett Squares as a warm-up to the lesson. They will have reviewed the terms asexual and sexual reproduction and their meanings, and they will have heard that we are going to be using model as a Play-Doh to demonstrate sexual and asexual reproduction. All right, boys and girls, so we are going to be using our Play-Doh to demonstrate asexual reproduction. So what I want everyone to do is take your Play-Doh, and we're going to assume that this Play-Doh is creating its first generation of offspring. So everyone cut your Play-Doh in half. Go undergo asexual reproduction and create your 2 offspring. Excellent. And now let's take both of your 2 offspring, and they're going to asexually reproduce as well. So take one. That's going to asexually reproduce. And your other one. Other offspring that's also going to asexually reproduce. And now if you could do that one more time, let each of your 4 offspring asexually reproduce. Excellent. Beautiful, Mother. Good, now Leo and Mother, you guys are going to be partners. Dad and Katie, you guys are going to be partners. Now I want you to look at all of the offspring that you have created asexually, and I want you to talk to your partner about what you see is similar and what you see is different with your offspring. Talk to your partner. What do you notice about the offspring?
There are different shapes and sizes.
All the same color.
Okay,
So they're all the
mine,
same
I see
kind.
everybody's the same color
But
and
they're
about
not
the same
all
size.
exactly the same
Mine
size.
are not the same size.
Not all
No,
exactly.
not exactly.
Well,
I
they're
know
not the
proportional
same
wise.
shape.
Excellent. Class. Oh, sorry. In one of our attention getters is going to be class, and you say yes, yes. Okay.
Oh, yes, yes.
Yes, yes.
Class.
Yes,
Yes,
yes.
yes.
So let me hear, Leo, what did you and your partner discuss? What were some similarities and differences that you guys noticed?
The different sizes and shape, and that were all the same color.
Good. Dad and Katie, what was something that you noticed or did not notice?
Well, they're all the same as well, so that there's not like a boy and a girl or something. They're all the same.
Excellent. Good. Good. Now go ahead and let's put all of your offspring together. We're going to mold that back into one parent.
My poor children.
And now what we're going to do is you're going to take your second color, your blue Play-Doh, and we're going to pretend now that we're going to do sexual reproduction. So you're going to have 2 different colors of Play-Doh in front of you. Now when you do sexual reproduction, as we know, you need 2 parents. So let's take one portion from your pink color and a little portion from your blue. And I want you to take those 2 and mold them together. You can mix the colors up, that's okay. And mix your colors up, squish them together, and create a child, an offspring, I'm sorry. Good, Leo. Good, now let's do that once more, still from the same parents. Let's do that again. Take another piece. One more piece from your pink and blue. Mold them together to create another child, offspring. Good, now I want you to look at what you have created here. Oh, good, Mom. And I want you to look at that piece, look at what we did before with our asexual reproduction, and talk to your partner about what is the same and what is different.
Different color for
But
at least the other parent.
I have different amounts of blue on mine.
Yeah, and
Yeah, see, so you have different amounts so
of each color
from the same
Right,
parents.
amounts. Yeah,
Turning
mine
out
are
differently.
definitely a
more
little different
integrated,
color
yeah.
and yeah, different
Mine are
sizes
smaller
as
than
well.
too.
Class.
Yes,
Yes,
yes.
yes.
Good, Katie, what was something that you and Dad noticed?
That we used both the same colors.
Mhm.
They each come from the same parents, but they still look different.
They look different. Good. Leo, what's something that you noticed?
How they are from 2 different parents, and the shapes in the sizes of them, even though, like Katie said, they come from the same parents.
Good. And how do these offspring look different than the offspring that we did with asexual reproduction? Talk to your partner real quick. How does that look different?
Well, they're different colors.
Colors.
Yeah,
Parents
they're
make
combined, yeah.
Yeah, and that really
combination
brought out
too,
a
and
lot
then
of
it
different
changes the amount of
sizes
combination as well.
Shapes and
and
stuff like that.
shapes and
Good. So,
colors.
Dad, what's the key difference between asexual and sexual reproduction? Remind us again.
Well, single parent versus two parents.
Good. Single parent versus two parents. So now, everyone, I want you to think back to when you only had one color. So go ahead and grab your pink again. And remember what we did when we had asexual reproduction. We created our offspring, and they all looked the same. So I want you to think about, how do you think that affects when asexual parents pass on genes to their offspring? Do you think they pass on all of their genes, only 50% of their genes, because we're splitting it in half, and then maybe only 25% of their genes? Try and use your colors to do asexual reproduction again, and talk to your partner about what you think happens with the genes that you're passing on to your offspring with asexual reproduction.
Same genes. Because your
So we
DNA
have
splits down the middle, but
one
it's 100%.
parent,
Yeah.
Right?
all the
It's not
same
like
genes.
it's not like in sexual reproduction where you get
So they're gonna,
half the
50-50.
DNA chain, half the
A
DNA
lot
chain.
the
Pretty-
same.
Yeah, pretty much identical.
yeah,
And they're going to pass on 100% of their genes because
All the genes from
they're just
Yeah.
splitting themselves up.
yeah.
And it's not being added or
It's
subtracted
almost
from
equal
anything
for
else.
genetic diversity.
Good. Mom, what do you think?
That having just one parent, you're gonna end up with kids that look exactly like the one parent. So there's not gonna be a lot of differences, they're gonna look a lot the same, and you're gonna have pretty much all the same thing that one parent had.
Yeah, good. So during asexual reproduction, 100% of the genes that the parent has gets passed on to their offspring every single time. So you'll end up with a bunch of little Leos if he asexually reproduced and made offspring of himself. There's a million little Leos around. And just because the parent is splitting in half does not mean that only 50% of the genes are getting passed down to the offspring. So now I want you to look at your two colors that we did when we did sexual reproduction. And I want you to think about, how does this remind you of your parents and what happened when you were born? Talk to your partner. What do you think? How does this look like them, or how does this remind you of what they did?
I might have gotten more
We have
gene from one side than the other. So
some
I got more blue than pink, or I got more
Traits,
pink than
genetic
blue.
traits show up more
Right,
And
or
then it's
less,
mixed.
depending
Yeah.
Right.
on how your
So,
DNA was
yeah, it's showing
recombined.
that
Sometimes.
So that even though you are theoretically
one
50%
parent
of
is
both
more
parents,
obvious than
the
the other,
dominant
depending
genes,
on what's showing up.
or recessive genes, as the case may be, are
Some
the
are
ones
more
that get
hidden, kind of
um,
inside. Here the
what
colors
do they
are
call that? Manifested isn't the right word.
little more pink.
You know
I
what
know,
I'm
I know.
thinking
what
for.
So,
you're
yeah.
Yeah.
That
both
it
of them are
becomes
kind of a
prominent, it
mixture
becomes
of
the one
both
that's
parents.
displayed.
Good. Class.
Yes,
Yes,
yes.
Good. I really liked Leo and Mom, what you guys were talking about. Do you mind sharing with the group what you were saying about the different colors and how many you see of each?
Oh, yeah.
We were saying that some are going to be more obvious on the outside, that one parent's traits might be more obvious to people, but on the inside you might have hidden the other parent's colors.
Hey, good
So
observation.
that's one thing we noticed.
And I said how much of each parent you get. So, for example, like maybe this has more blue than pink, or pink than blue.
Good. Dad and Katie, what were some of the things that you guys were saying?
Well, we were saying that even though you have different amounts, again, on the outside, when you combine the two halves of the DNA, sometimes recessive genes are shown and displayed, and sometimes dominant are shown. So that even though you're getting the same 50-50 mix from the parents, how they are combined in the DNA determines how you look on the outside.
Good. Good, Katie. Anything else you want to add to that?
I don't think so.
Okay, so what we're going to do is, just like we did those Punnett Squares earlier, you can go ahead and put all your offspring together. We're going to make some Punnett Squares. Go ahead and put your pinks in the pink jar. And those in the blues.
What about
The mixed kids, you can just put on the orange cap here. Whoops. can go ahead and flip your tray over so you have a nice smooth surface to write your Punnett Squares on. Alright, so we are going to look at all of our offspring here, and we're going to show how we create that offspring using Punnett Squares. So we saw how we did it with our Play-Doh. We moved all of our Play-Doh around. We're going to see how we do it using Punnett Squares and looking at the genes that we find inside. Alright, so remember for genes, we have our dominant and our recessive gene. Remember, dominant gene is the one that usually shows. Recessive gene is the one that is hidden. So what we're going to talk about is our, we're going to call this, I know it's pink, we're going to call it red. Red and blue Play-Doh. So what can you guys tell me about the texture of the Play-Doh? Was it hard, soft, feathery, squishy? What would you say?
Squishy, soft.
Squishy, soft. Good. So what we're going to do, we're going to make our recessive gene the squishy factor of, our Punnett, or our genes. So we'll go ahead and write down all 4 letters that you see here. And has anyone ever dealt with hard Play-Doh before? Has anyone come across that Play-Doh before?
Yes.
Play-Doh that's gotten hard. So not all of our Play-Doh is going to be squishy. So what we're going to do is our capital R is going to be the color of our Play-Doh. We're going to call it red. And our recessive gene, because Play-Doh is not always going to be squishy, it may possibly be hard, is going to be our squishy factor. Let's write squishy. And then same for our blue Play-Doh. Remember, our dominant is the color blue, and our recessive gene is the squishy factor.
Wouldn't it be hard?
Why would it be hard?
The recessive for both of them are squishy?
Mm-hmm.
Oh.
Was your Play-Doh, your blue Play-Doh, was it hard or was it squishy?
Oh, no, I thought you were talking about hard, for example.
Oh, no, we're looking at, so
Oh,
let's
my
remember,
God.
yeah,
Oh,
the
okay.
Play-Doh that we used.
Oh, okay.
So what we're going to do is we're going to set up our Punnett Squares like we've done before. So remember, you put capital R and our lowercase r here. And then our capital blue and our lowercase r. Or B, I'm sorry. So I know you guys know how to do Punnett Squares, but we're going to do this first one together. And then we can do some more that you can try on your own. So remember, with Punnett Squares, we're going to look first at this letter, capital R. And then look here, capital B. And then we'll look here, R, capital R. And go down, lowercase b, lowercase r, and capital B. And then lowercase r and lowercase b. So I want you now to turn to your partner and talk to your partner about what you think these mean and how does that relate back to what you did with your Play-Doh. What do you think these letters mean? And if you're not sure, that's okay. You can just talk about what we did with our Play-Doh. Maybe it'll help jog my memory.
You have dominant red and blue, so it's going to turn out
two different types of
red
genes
or blue or some combination
and
therein.
from different
And
Play-Doh
over here,
from
it's
different
going to
Play-Dohs.
be red
You can
Play-Doh
combine
and
together and they
squishy.
create different,
Here is
like,
going to be
offspring.
squishy or blue Play-Doh.
Good.
And here
Okay.
it's just going to be squishy
So like
of
this one
unknown
is
color.
squishy
We can't tell
and
from
blue,
Yeah.
so the
Punnett
squishy
Square
would
whether
be
it's going to be
kind of
squishy or not. Just like
not
on this
as
one,
much
we can't
as
tell
blue.
whether
With the texture.
That's
the
what I'm
texture will
thinking,
be.
that you would notice it's more blue,
because we don't know because they're both dominant.
or
Yeah.
this one's a,
And we're only expressing
Squishy.
dominant now, whether or not.
it's just squishy, and the color
Well, yeah, we're not expressing a recessive gene there, so we can't
not
really
as,
say
it's
more
more
beyond
hidden.
that.
Yeah.
Good.
So
Class,
these two
class.
recessive.
Yes,
Yes.
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 Let's see, Katie and Dad, what did you guys, what do you think is the connection between what we did with our modeling for Play-Doh and what you see written on your Punnett Square?
Well, we saw that in the upper left square, we're only expressing dominant genes. So we can only say it's either going to be red or blue or some combination, but we can't say whether it's going to be squishy or not because we don't see that. expressed.
Well, and how do you know that you're not seeing the squishy expressed? Why do you say that?
Well, we don't have, the gene is not being, you're not expressing any recessive gene in the square at that point.
Good, right. So Dad is saying that even though we have our capital R and our capital B, which we see is red and blue, he said we might see red and blue, we do not see our lowercase r or our lowercase b, which will be our squishy factor. Good. What else did you, or you know what, Mom and Leo, what did you guys notice? Thank you, Dad.
Mm-hmm.
We were talking about the lowercase r and b and how that would be mainly squishy, and that you would just kind of know it was squishy, but you really don't know anything about the color.
Good. Good. And why? And explain to me, how do you know that you don't know anything about the color?
There's no indication in that particular combination of genes that expresses it for you. It's just the R and B being squishy.
Good.
And
Right.
saying, those are it. That's what you're going to see the most.
Excellent. So yeah, let's look at each one. So like we were saying, in our first offspring here, or our first mix, we have our capital R and our capital B, which, yeah, was going to be red and blue, but we don't know if it's going to be squishy at all. And then here we see our capital R, which is the color of red, and our lowercase b, which is our squishy factor. So what do you think, Katie, that would mean? If we have our capital R and our lowercase b.
That it's going to be red and squishy.
Red and squishy, good. And then we have our lowercase r and our capital B. So we said lowercase r means squishy, and capital B means blue. So that's going to be squishy and blue. And good what you guys said with our R and our B, Leo and Mom, that it was both squishy, but we're not sure if there's going to be red or blue colors represented. Excellent. So now we're going to switch it up a little bit. We're going to try something a little different. We're going to have two dominant R genes. So we're gonna pretend that the Play-Doh that we just did, our pink Play-Doh, had been sitting in the closet for a really long time, and nobody had opened it for 17 years, and so our Play-Doh got really hard. So let's draw another Punnett square, and let's write down now the 4 different things that you're going to be working with. 4 different genes that you're going to be working with. And since I know you guys know how to fill out Punnett squares, once you've set up your Punnett square and shown your partner, you can go ahead and fill it out. I want you to check that your partner's Punnett square is set up correctly. If it's not, go ahead and tell them or show them how you set up yours.
Would the second R be hard, or no? Because if it's the pink and it was hard, would it be the second capital R be hard instead of
Well,
squishy?
remember we said that capital R means red, and if we had an only red Play-Doh and there was no squishy factor in there, then we're going to assume that it's hard, that it's not squishy. And once you check with your partner, you can fill it out.
Dang it. Don't copy off me. I'm done. I'm checking you. That looks right.
Oh, you guys,
All right, so check to make sure that your Punnett square looks like mine. So we have our capital R, capital B, capital R, capital B, capital R, lowercase b, and capital R, lowercase b. So there's something different about this Punnett square, and I want you to see if you can find it, and if you can, turn to your partner and whisper it to them. See what's different about this Punnett square? Whisper it to your partner.
Okay.
And if you have an idea, give a thumbs up. If you have an idea, give me a
I
little
think I
thumbs
have
up.
an idea. I'm pretty sure I'm right.
Okay, well, Leo thinks he's pretty sure he's right, so let's hear your idea.
Well, would there be no blue Like none of the offspring would be blue, like completely blue, because like it's not with a recessive gene, it's always with another dominant. So there would always be a 50-50, right? No.
That's good, Leo. So what Leo is saying is that we see our capital R color, which means we have our red color, everywhere in our Punnett square. There is no place in our Punnett square that has a lowercase r. So he's saying that in our first square, what would this offspring look like, Mom?
It could be red or blue.
Yeah, it could be red or blue, or it might be a mix of the red and blue. So that knocks out then both of these. They're not going to be blue, 100% blue at all, which is what Leo was saying. Good, you might be a mix. And what's going on here? What are those two going to look like?
Dominantly red.
Dominantly red, but what does that lowercase b stand for again, Katie?
Squishy.
Squishy. So it's going to be red and squishy. Good, excellent. So let's do one more now. So we're going to go back to our original, where we had our capital R and our lowercase r. So we're going to pretend our Play-Doh has not been sitting in the closet. And we're going to change our blue this time. And he's going to be only squishy. We're going to have an only squishy blue. Or only squishy B, I'm sorry. So go ahead and set up your Punnett square using these. Same thing, check with your partner before you fill it out. Make sure you guys are set up the same way. And then fill it out and talk to your partner about what happens now when we have lots of squishiness, but not necessarily as much color.
Yeah.
Now we're kind of stuck.
We can't be.
It's all except for
red,
oh, no,
squishy,
the bottom two.
squishy.
Good. So, Dad, what did you guys notice?
That all of the offspring are going to be squishy.
Mm-hmm.
There's only one color option, so only red will be expressed genetically in the top two. In the bottom two, there may be no color expressed because there's no color gene component.
Excellent, very good. So Dad, notice that in every single situation, we see our lowercase b or our lowercase r, but mostly our lowercase b. If we look at every single one, lowercase b, which means that we have squishiness represented in every single one of our offspring. Excellent, Dad. Good work. Okay, we can stop it there.